Did you know that a giraffe's neck can be up to 2.4 meters long, about half the length of a small car? With a total height that can reach 5.5 meters, the giraffe is the tallest land animal in the world. But why do these majestic savanna animals have such long necks? It's not just to be taller. Stay with me, because the answer reveals an incredible evolutionary process. The long neck of giraffes has been a subject of fascination for centuries. What seemed like a simple adaptation to reach higher branches turns out to be much more complex. Scientists have proposed several theories, and although the debate remains open, recent research allows us to better understand this spectacular evolution. The giraffe's neck is not only a biological marvel, but it also tells the story of evolution in one of the world's most extreme environments, the African savanna. One of the best-known theories supported by scientists is that the long neck of giraffes allows them to feed on leaves high up. But is that really the main reason? For a long time, researchers believed that the long neck of giraffes had evolved primarily to allow these animals to feed in the tallest trees, thus avoiding competition with other herbivores. In particular, acacias, thorny trees often found in African savannas, become almost exclusive food sources for giraffes, as their height exceeds that of other herbivores such as zebras or gazelles. This theory, called the food competition hypothesis, is widely accepted and supported by studies on the feeding behavior of giraffes. Research has shown that giraffes spend about 60% of their time eating leaves located well above 2 meters from the ground, a height inaccessible to most other animals. During periods of drought, when food on the ground becomes scarce, this ability to reach higher branches becomes a valuable asset. Scientists have observed that in areas where giraffes coexist with other herbivores, such as elephants, these animals occupy different food niches. Elephants, which can also reach high branches thanks to their trunks, often eat the lower branches, while giraffes focus on the higher parts of the trees. This reduces competition for food and maximizes the chances of survival for both species. However, this explanation by the search for food may not be the only reason behind the evolution of this long neck. Although this theory is widely accepted, it does not explain some observations, such as the fact that males have even longer and heavier necks than females despite a similar diet. This opens the door to another equally fascinating hypothesis: sexual selection. What if the long neck of giraffes was not only an adaptation for feeding, but also for seducing and dominating? In addition to feeding, there is another explanation that could play an essential role in the evolution of the giraffe's neck: sexual selection. This theory is supported by observations of social behaviors of male giraffes, particularly the fights called necking. In these fights, male giraffes use their necks to fight, hitting their opponent with headbutts. The male with the longest and most powerful neck usually has the advantage, and these fights often determine which male will access the females to reproduce. Necking is a fascinating spectacle to observe. Two males stand side by side and begin to swing their heads and necks like clubs, hitting the opponent in an attempt to unbalance or knock him out. These fights can last several minutes, and they are often violent. Giraffes use their ossicones, the horns on their heads, to inflict harder blows. The male who emerges victorious from this duel often wins the right to reproduce with the females of the group. Studies have shown that males with the longest necks are more successful in these fights, reinforcing the idea that neck length is directly related to the ability to reproduce. Thus, sexual selection has probably contributed to lengthening the necks of giraffes, with the strongest and most imposing males being more likely to pass on their genes. However, it is interesting to note that even female giraffes have long necks, although they do not participate in necking fights. Having a long neck is an advantage, but it also brings major challenges. How do giraffes manage to handle such a large body? The long neck of giraffes, although advantageous for some reasons, also presents serious physiological challenges. For example, to ensure blood flow to the brain, which is located at a considerable height, the giraffe's heart must be particularly powerful. In fact, a giraffe's heart can weigh up to 11 kilograms, which is gigantic compared to the human heart, which weighs only about 250 to 350 grams, and it generates blood pressure twice as high as that of most other mammals. Without this adaptation, it would be impossible for the giraffe to pump enough blood to its brain. But the challenges don't stop there. When giraffes lower their heads to drink, they are faced with another problem. The massive flow of blood to the brain could cause fainting. To avoid this problem, giraffes have developed an ingenious system of valves in their blood vessels, allowing them to regulate blood flow. This adaptation prevents giraffes from losing consciousness when they bend down to drink, a remarkable physiological feat. Another curiosity lies in the structure of the giraffe's neck. Although their necks are extremely long, giraffes, like almost all mammals, including humans, have 7 cervical vertebrae. The difference is that in giraffes, these vertebrae are elongated and articulated in such a way as to allow for amazing flexibility, which allows them to stretch and bend their necks with agility. In addition, the muscles that support the giraffe's neck are very powerful. Tendons and ligaments help maintain the position of the neck and reduce the effort required to keep it straight. This ingenious system allows the giraffe to maintain its balance and posture, even with such a long and heavy neck. The ancestors of modern giraffes did not always have this elongated neck. What do fossils tell us about their evolution? The first giraffes did not have necks as long as today. Fossils of giraffids, the ancestors of modern giraffes, show that these animals had much shorter necks and lived in more wooded environments, with less competition for food at height. Over millions of years, the African savanna replaced forests, offering open spaces but with higher vegetation. This ecological transition probably favored giraffes with longer necks, able to feed on the leaves of the tallest trees. Climate change and the pressure of competition for food would have accelerated this evolution. A fascinating example of this evolutionary transition is that of Samotherium, an extinct species of giraffid that lived in Europe and Asia about 8 to 12 million years ago. Samotherium fossils show a shorter neck than that of modern giraffes, but longer than that of its ancestors. This species is often cited as an example of an intermediate stage in the evolution of modern giraffes, illustrating the slow transformation of their morphology over time. The neck of giraffes is much more than just an appendage. It is the result of an incredible combination of environmental pressures and sexual selection. Whether it is to feed or to dominate in the competition for reproduction, the long neck of giraffes is a fascinating example of evolution in action. This neck, both an asset and a challenge, testifies to the ingenuity of nature to overcome complex physiological obstacles. So, the next time you see a giraffe stretching its neck towards the branches of an acacia, remember the incredible evolutionary story behind this iconic animal. This long neck is a true masterpiece of nature. I hope you enjoyed this video. Don't forget to share your thoughts on this fascinating subject in the comments, and subscribe to discover other wonders of the world around us.